In this lecture, we're going to discuss how to represent the solubility of a compound. We're going to do that by expressing a ratio of the solute to the solvent. And the way we typically do this is by just expressing how much solute we have compared to the entire solution. And that entire solution, remember, is the solute plus the solvent. And when looking at a combination of two different things that are dissolving in one another, it's important to remember which is which, solute and solvent. And so something that's, let's say, 2 grams of sodium chloride dissolved in 100 grams of water. In this case, whatever is the smallest one will be the solute. And the larger one will be the solvent. So the solution in this case would equal the 100 grams plus 2 grams, or would be a mass of 102 grams. That's tracking mass. Now there are a couple of different ways to track concentration. If we're going to use a ratio of the solute to the solution, we typically represent it as a mass percent, which will describe typically solids, but it describes the mass of the solute versus the mass of the solution. Or we'll do volume percent, which describes the volume instead of the solute compared to the solution. We use this one a lot to represent aqueous ethanol concentrations in like beverages like wine or beer. In the hospital, especially when we are using solutions that had a solid that was dissolved in a liquid, which happens to be a lot of our IV solutions that are salts dissolved in water, mass percent is commonly used. And that'll be the mass of the solute divided by the volume of the total solution. And then the one we use in chemistry labs is molarity. And this is going to be a ratio between the moles that we have of solute and the volume of solution. And we use this because we so often need to convert into moles to predict the amount of our product. It's easier for chemists to work in units that already incorporate moles into it. So we're going to walk through each of these one by one and discuss how to calculate them. Overall, if you were going to focus on anything, I would focus on mass to volume percent, because I think you see that the most in the medical field, and molarity, because we'll need to use molarity to perform chemistry labs. Let's start with mass percent. Mass percent, volume percent, and mass to volume percent are extremely similar. It really just changes between the three, the units that you use. So the mass percent of a solution is going to be equal to the mass of the solute on the top of a fraction divided by the mass of the solution, which will be that solute plus solvent. And we multiply it by 100%. And be careful, because some calculators, is really multiplying it by 100, and that gives you a percentage. Some calculators have a 100% button that doesn't just multiply it by 100, it multiplies it, I think, 0.01. You get weird answers. So I would double check. So here's kind of the way to represent that too, if you know the mass of the solution already. So typically, we like to think of the mass percent as just being a number then that tells you the amount you have of solute if you had 100 grams of solution. That's basically what this is saying. So in the previous example, we said, let's say we would set this up as saying our 2 grams of sodium chloride would be divided by the 102 grams of our solution. And we would multiply it by 100 to get a mass percent for our actual solution overall, which would equal 1.96%. So volume percent, again, is similar to mass percent. It's going to be the volume of a solution divided by the volume, or the volume of a solute divided by the volume of a solution, rather than the masses of these two things. So it's a very similar ratio. And you would use this if you knew the volume rather than the mass of both your solute and the solution. So if I had something like 5 milliliters of methanol combined with 95 milliliters of ethanol, I would say that my volume per volume percent would be equal to that 5 milliliters of methanol divided by 100 milliliters of solution. Again, my 5 milliliters is the smallest volume I have of these two that are mixing, and so it's going to actually be the solute. And then I multiply this by 100 to get 5%. And these are going to have units other than percent. You want to specify its volume per volume percent instead of mass per mass. Sometimes write 5 volume per volume percent, something like that. Mass to volume percent, again, is going to be the solute over the solution in terms of our ratio. This time it's going to be the mass of the solute divided by the volume of the solution. And again, multiplied by 100. And so in this case, we might have something like I have 2 grams of sodium chloride, and I add enough water to form a 100 milliliter solution. It's commonly how it's stated. So you have to kind of watch for the context of the problem. If it says 100 milliliters of water is added, well, that's going to be the volume of your solute. And you'll need to determine the actual volume of your, solvent. The 100 milliliters of water is the volume of the solvent. And you would need to add to that the volume that your solute took up. Commonly, it'll state instead that you'll have 100 milliliters of solution or water is added to form a 100 milliliter solution. In that case, you would divide these two times 100 and get a 2% mass per volume concentration. The thing that's interesting about this one in particular is that you utilize units that are very similar to density. So it's important for these ones that we get our units correct in terms of the size of our volume units. It needs to be milliliters. If we did grams per liter, we would need to specify that that's what we were using. But since we typically just say a percent or mass per volume percent, whenever you use these units, it'll be assumed that you're using grams per milliliter. This is one of our abbreviations in chemistry that we rely on so heavily that we are going to make this assumption and just assume everyone knows that's what we're doing. So grams per liter would be a very different number. It would be off by 1,000. The other thing that's kind of tricky about this is that these units are the same units as density. And these are two very different things. Density is a physical property. While it changes a bit with temperature, it's not going to change from situation to situation, like with a concentration will. So my sodium chloride will always have the same density at a temperature, but I can have lots of different concentrations of sodium chloride dissolved in water. And so concentration is a ratio, whereas that is circumstance dependent, whereas density is a property that's inherent to the chemical identity of what you're talking about. Molarity is the big one for chemists that we use a lot because we like moles, because we have to do a lot of stoichiometry problems. And this one is going to still be a ratio of solute over solution. The difference being that we're going to use moles of our solute, and our solution volume is liters rather than milliliters. So between mass per volume and molarity, there's typically a conversion that needs to happen to go from grams to moles, but also milliliters to liters if you're going in between the two. So if I had a 3 molar solution of sodium chloride, it would mean I had 3 moles of my sodium chloride that were dissolved in water until I had a total volume of 1 liter. Give these practice problem or this practice problem a try, and there'll be a separate video with a detailed solution.